the additive manufacturing process just allows you to dream. It really takes your handcuffs off and allows you to do things that you never thought you could do.
Solutionology is about being unyielding with perseverance to get to the solution. You've had such a fantastic career. Most of it's been focused on Cirrus, but you've got this other life. Well, there's probably more than one. We know that there's more than one character here. But you've also got your own design firm, right? And you're also working on other projects outside of your day job, so to speak. I don't know how you pull it all off. But we've worked together on other projects that aren't Cirrus related. And there's a couple of them that are of particular interest. It would be neat to talk through a couple of those. One's a camera body that you designed. It's gone through several iterations, but the design characteristics that you've employed are, mind-blowing. They're next level. Would you mind just talking a little bit about that program?
Yeah, sure. I had left Cirrus in 2009 at the end of the housing crisis recession. And really, I was burned out. Also, I was just really tired. I was a very, very intense 10 years. I went to Sikorsky Helicopter for 4 years. And then after that, started my own business called Staagen Design, which is basically a product design firm. And I do still have that today, although it's running on, it's now orchestrated with my Cirrus career. But during the 8 years that I was doing, 9 years that I was doing Staagen Design full-time, I did several projects that were really neat. The camera project is absolutely one of my most favorite ones. And it's just so funny how things work out. What I was trying to do there, working with a company that had the skills to create all of the internals of the camera. Well, they had no mechanical design or industrial design capabilities, and I got a phone call and from them, and they wanted to see about if I could provide that service for them. The best part about that particular project was that I wasn't really competing with anybody inside the company, so it was really free to do whatever I wanted. Now, they provided an idea, an envelope. They said, "Hey, I want it to look like this," and as the way I am, I'm trying to make the customer happy. So we went with their exterior design and their design requirements. But then it became an absolute challenge. And the challenge was putting 10 pounds of potatoes in a 5-pound sack. The overall size of this camera was small, about the size of a can of soda. But the camera is extremely powerful, and it does onboard processing, which was revolutionary at the time. And it still is. And so anyway, we had to figure out how to do this and make it. One of the benefits, though, of this company is that they weren't this isn't a discount camera. This is a professional camera used in very, very special circumstances, situations. So I knew I had a little bit of runway, a little bit of room to do some things like machine metal parts. And the exterior had to be very robust. Wasn't quite waterproof, but it has to be sort of dust and dustproof. One thing led to another. As we started to put the camera together, I was trying to figure out how to build it to where I could satisfy the exterior design requirements. I could pack everything that was in there. And of course, the camera also had like 3 versions of it. And so about 1/3 of the camera had different kinds of components that had to go in there. So it had to have some versatility to the design as well. And as we got started, and this is how I met you, actually, on this particular project, I had bought my own MakerBot printer in 2011. So I was doing additive manufacturing back then, and wanted one even earlier than that, like one of those rip-wrap ones that you make out of plywood at home or whatever. But I had my MakerBot printer, and so I knew what additive manufacturing could do for prototyping, but I hadn't quite thought or never had the opportunity to think of additive manufacturing for a production solution. And through our friend, I got to meet you guys and started to talk about what would the potential be for using additive manufacturing in this camera, and what the process that you brought me into that I learned about and now love is your MJF process. What I really liked about it was the toughness, the stiffness, and how thin and small the parts could be, and the accuracy and consistency that came from it as well. So after we got started and made the first couple prototypes, instantaneously gained confidence that this was a great solution, because we know we weren't going to build more than 150 cameras, right? So we really couldn't figure out how else to build the inside of the camera in a way that could be produced. Well, what another accidental discovery thing that happened during this time was that I was able to I started the process of consolidating the internal frame. So there's an internal piece inside the camera that has to hold the circuit cards and the lenses. It needed to have places to hide wires. It had to hold switches and had lots of different kinds of ports on the back, audio ports, audio jacks, Ethernet cables. Well, I had to hold all of this stuff together inside of this external shell. So I was playing this off. Okay, the shell is made up of 4 or 5 parts. You have to assemble it together. It's full. The camera is 100% full. There's very little air inside of it. And we had to find ways to get the heat sinks from the circuit boards. There's 5 circuit cards inside. How to get the hot chips that were heavy processing chips. How do we get the heat to the outside of the camera so it could be dissipated? And I started down the road of having like 5, 6, 7 frame elements inside. Some things were attached to the aluminum external parts that were going to be machined, and it just was sort of falling. It wasn't coming together. It wasn't converging on a great solution. So what was really neat was I started to realize that I could make what I call impossible parts. I think if I did not have this ability, I don't think we could have come up with the elegant solution that we came up with. And what we had, what we ended up getting to was a single printed part on the inside that literally held over 20 components together, and it was used to hold the whole camera together. What blew my mind was, as you guys clearly remember, is the requirements for the camera actually came out over about a year-long process, because the company building the camera was also developing ideas and learning, and they're like, oh, we got to add this card, we got to do this, and we get a phone call and they're like, hey, guess what? And I'm like, what? We got to put another board in there. I'm like, well, where? Well, it has to go to the outside for heat, and it has to be close to this, and it can't be in front of that. And it was just and never do I get upset about those kinds of things, but I was just sort of feeling the weight of the challenge. So we were able to take the designs. We were building iterations, and I was able to add this new feature, this new bracket, this new thing onto the current design. And several days later, I would get a nice box from you guys, open it up, put it all together, and voila. And so we were able to drive all of this complexity into the printed part. And why that why that is important is because I was able to draw the cost out of all of the other components. So now I could have these very simple metal parts that were, typically 1 setups on the machine. We know those are always good guides, always good things to have. But we were able to drive all the complexity into your technology. And what was neat about that is the last time I checked is your machines really don't care how complex the parts are, right? A person running a machine or a lathe or something, the mill, they care. It's very difficult to set up, and there's multiple setups and yada, yada, yada. The cost goes out through the roof. But what I felt was the biggest gain was that I could just simply keep adding onto the single internal frame part, and that worked great. They built the cameras. It has been phenomenal. We were able to tweak things. We were able to 2000s makes a difference when I'm trying to decide how big a part could be. Normally on our machine parts, we're plus or minus 5,000s, and it costs a lot more to get that down. But we were able to consistently get down in the 2000s range of accuracy. I was able to do all kinds of little extra features in the part, like little snaps to hold things in. I mean, I was able to incorporate wire runs and things to hold wires, little clips, so we didn't have to have zip ties or any kind of tape. Or we were able to add access holes where you never thought you could create one, so you could get in and do some work. And so that project really sort of opened my eyes to just how far you can push it. And at this point, when I start a new project, it's my go-to because it's such a versatile tool. It's such a versatile component in the design process to be able to have something that can have basically it's living. It's a solution that can grow with you. And when you try to add to it, it doesn't fall apart. The additive manufacturing process just allows you to dream, if you will. It's it really takes your handcuffs off and allows you to do things that you never thought you could do. And I've used that in every single project since that. So now that I have the confidence that the process can do that, I start out in sort of third gear, if you will, not first gear, second gear. I just start out in third gear because I just confident that I can make it happen. The last project that we did together that you just mailed me was a very intricate little mechanism that it ended up being too small for manufacturing, but the concept worked and it worked great. But the human ability to go in and make these little soldering connections is where it sort of fell apart. But we were able to create these tiny little snap together parts in a way that removed the fasteners and just made it click together. That type of thing is so interesting to me because of what you can accomplish. The fact that you can literally bring 10 or 12 or 15 parts together into a single part is just such a powerful tool that additive manufacturing really excels at. And what's neat about this is once you realize this, it really, especially if you're coming from somebody who's making things out of typically machine parts or something on some kind of CNC part, this is like a breath of fresh air. And if you can deploy it in the design in such a way that you can leverage it, there's no downside to it. It really is positive.
Thank you for sharing that fascinating story. And it's really fun to go back and think through all the different iterations that you had on the camera body and where you started with several components. And then I was just looking at some of the extra components that we have and thinking back to how you eliminated the fasteners and then added the snap features and then added the wiring snaps built in. I just love thinking about that journey and how you continue to push the boundaries and explore how you could simplify the ultimate assembly by consolidating the components. The latest assembly that you sent us with the snap features, I know as soon as I was copying, I think you sent that to me, and as soon as I received it, I shared it with Brian and said, "This is genius. This is just awesome." Yeah, so I get a kick out of it's just you're an amazing designer. You're such an amazing designer.
Well, thanks. That's your support, guys. That I love your tagline. There's always a solution. I use it all the time. In fact, I steal it and tell my guys that the answer is always yes. And the reason you can always say yes is because there's always a solution, right?
Right. Really appreciate the time. This conversation I feel like could go on for hours and it wouldn't get old, and it never does. So really appreciate the time that you've spent with us here today, Mike. I appreciate being able to work with you, bounce ideas off of each other, and everything that we get to do together. You make what we do worth doing. So really appreciate that.
Thanks, guys. I really appreciate your time, and thanks.
Thanks so much.
Thank you, Mike.